Okay, good morning all of you. We are discussing about the preparations of the colloids or nothing but source. Already we learned some techniques like condensation method, dispersion method. Under condensation method, we are using so many chemical reactions and we are preparing source. And under dispersion method, we have one technique, that is electric column method, yesterday. And we have one more method for the preparation of the source, nothing but peptization. Relatively, it is an important topic. You see carefully. Peptization, what is the basic concept of here? We have to take a freshly prepared precipitate has to be taken. Okay, means for example, you have this much of size we have. Compulsory size should be more than 1000 nanometers. Precipitate means is it single particle? No, it is the group of particles. Yes, sand you take. Sand which is not a single particle. So many sand particles are aggregated together. Its size should be more than 1000 nanometers, falling as a precipitate. That's why in this what happening? So many small sized particle will be there. Yes or no? Yes, like this will be there. Okay, to this precipitate, I am doing something. Means I want to make it as a sol by doing something. For that, I am adding electrolyte. I am adding. Compulsory condition: the adding electrolyte should having common ion with precipitate. The adding electrolyte having common ion with the PBT. I will explain later by taking so many examples. First, you see. Okay, first of all, how to take a freshly prepared precipitate? Sir, why not old PPT? If you take old PPT, what happens? It's becoming very hard. The decomposition will be difficult. That's why just now prepared precipitate we have to take. To that we should add electrolyte. The adding electrolyte should having common ion with the precipitate. Then this whole precipitate will be break down into small pieces under size of colloidal particles. Means it will be break down into small pieces. Those particles only we are calling as colloidal particle. Size should be range is how much? 1 to 1000 nanometers. The whole phenomena is calling as a peptization. Peptization means a freshly prepared precipitate will be converting into sol by adding electrolyte which is having common ion with precipitate. Whatever common ion with precipitate will be there, that is specially calling as peptizing agent. Peptizing agent means the whole things will be depending upon this common ion. Did you got once again? The freshly prepared precipitate will be converting into sol by adding electrolyte which is having a common ion with the precipitate. Then the precipitate will be break down into a little bit smaller size particle under range of colloidal particle. Phenomena is calling as a peptization. Whatever common ion from the electrolyte will be there calling as peptizing agent. Just you see, I want to take one freshly prepared precipitate of silver iodide. Concept understand very carefully. It is the precipitate of silver iodide. Okay, it is made up of so many smaller silver iodide particles, though all are aggregated together becoming like a precipitate. Compulsory size will be more than 1000 nanometer. Okay, now I want to break down this material into colloidal particle. For that, what I should do? I should add one electrolyte. Electrolyte means what? 100% decomposition has to be takes place. For example, I am adding Ki. Is it enough? Yes. Why? In this adding electrolyte, after decomposition, what happening among K plus I minus. So I minus is the common ion with precipitate. In the precipitate already iodine is there, and here also iodine will be there. It is acting as a peptizing agent. And also other than K, I can use one more. Yes, you can use it. What is it? What is it? You can use silver nitrate. Silver nitrate is decomposing like Ag plus and NO3 minus. Ag plus is the common ion with precipitate. We can use either Ag and NO3 also. It's not a condition. Okay. After adding this one, what happens? This I minus whatever will be there, that common ion is undergoing adsorbing on the surface of the colloidal particle. Everyone is AgI particle. On those AgI particle, it will be undergoing sticking I minus. After that, what happening? AgI is becoming like a negatively charged particle. Like that, all AgI particles is becoming like a negatively charged particle. Then they stay together. They are staying together. No, why? Like charge. That's why like charges is always having repulsive forces. Then what happening? The whole material will be break down into a smaller size particle under the range of colloidal particle. Then we are getting a little bit smaller size particle, that is nothing but AgI. All iodide particles or carries negative charge. Are you getting or no? Yes. Now we are getting like this. So this is nothing but colloidal particle carries which charge? Negative charge. That's why we are calling this soul as negatively charged soul or negative soul. And compulsory this size should be 1 to 1000 nanometer. All of you getting that? Yes. This is the phenomena is going on. I will give you one more example. If you take a freshly prepared ferric hydroxide soul, yes, FeOH taken thrice is the PBD. PBD means having very big size. This size is more than 1000 nanometer. But in that so many, what will be there? FeOH thrice particles is there. Okay, already this everyone is FeOH thrice particle. This one. Okay, if together means calling as a precipitate. So I have to break down into colloidal size particle. For that we should have electrolyte. What is the peptizing agent here? I minus is the peptizing agent because it is only involving that peptization. Now, to this I should add something. Yes, we can add compulsory strong electrolyte should be. KOH we can add, very good. If you add the KOH, what happening? From KOH which is undergoing sticking here, OH minus because common ion. Then all colloidal particles are becoming negatively charged, repel together and break down into small pieces under the size of soul. And now I want to add for example FeCl3. Is there any problem? No. It is also strong electrolyte because metal non-metal combination like a salt behavior. Then it will break down into Fe plus 3 plus 3 Cl minus. What is the common ion here? Fe is the common ion. Enough is acting as a peptizing agent. What it will do? It will be sticking on that FeOH thrice precipitate particle. Then every particle is becoming a positively charged because of the same charge. They repel together. The whole material will be break down into some small sizes pieces. Then we are getting like this particle. We are getting little bit smaller size. FeOH taken thrice. After that it is getting Fe plus 3. So here also FeOH thrice or that Fe plus 3 is coming like that. Every colloidal particle carries Fe plus 3 means anyway positive charge is carrying. That's why it is calling as positively charged soul. Based on charge on colloidal particle. Later will come so much information we will discuss over there. Based on charge on the colloidal particle, we are giving name to that like positively charged soul or negatively charged soul. All of you getting that? Yes. Now we have to discuss some important methods here. Purification. Purification of souls or colloids. What is the necessity to purify the souls? What is the necessity? Just now we did. I will write first some concept while preparing souls. We are adding little amount of electrolyte. We are adding little amount of electrolyte. Yes, this one only na? Yes. After adding electrolyte, if sufficient is there, all colloidal particles are becoming charged. Okay, then it is becoming stabilized. Once again I am telling, while preparing source, we are adding little amount of electrolyte. In that some amount of electrolyte we are adding. In that little amount of electrolyte is enough for stabilize soul. Are you agreeing or no? Are you got my point or no? Yes, in this you are adding, for example, 5 grams you are adding. Just 2 grams is enough to becoming like a sol. But remaining 3 grams will be excess. It cause damage. So whatever you are adding electrolyte from outside, in that very little amount of electrolyte is enough for stabilizing the sol. Stabilizing is what? The disposal phase should interact with always dispersion medium. If settle down, calling as a precipitate, lose its sol behavior. Now, what I am telling, if excess of little amount is enough, but remaining amount is dangerous towards, means it's damage the sol behavior. Means if excess of electrolyte is there, because of excess, what happening? The sol is becoming like a precipitate. How it is? For example, you have AgI particle will be there already on it. I minus is there. You added 5 grams of Ki, but still 3 grams of Ki is remaining. Then what happening? This Ki is still undergoing decomposition like K plus plus I minus. What happens now? Yes, very good. In the sol, what is more? K plus particles is more. Because of K plus particle more means positively charged particles is more. Whenever positively charged particles is more, then what happening? They are absorbing negatively charged particles on the surface of the colloidal particle. Then what happening? It will becoming like Ki. After becoming like what happening? Silver iodide colloidal particles are carrying any charge? No, they are becoming chargeless. They are becoming chargeless means is there any attraction or repulsion? No repulsion, because what happening? No charge. That's why what happening? There is no repulsion, there is no attraction. But they are heavy particle. Heavy particle means what happening? They are aggregate together, becoming like a precipitate. Initially we are taking a sol, but in that sol, because of excess of electrolyte, what problem is going on? The sols are becoming unstable. Means sols are converting into precipitate. How? From electrolyte, whatever positively charged particle is there, they will absorb the negative charge from the surface of the colloidal particle. Then colloidal particles are becoming chargeless. Then they aggregate together, becoming like a precipitate. The whole phenomena is only we are calling as coagulation. I explained under where leophilic and leophobic sols stability. What happening? Sols are becoming precipitate. The phenomena is calling as precipitization or also calling as a coagulation. Now, if I want to maintain the stability of the sol, what I should do? Yes, very good amount. Whatever excess of electrolyte will be there, that should be removed. That's only target. That's only calling as purification of the sols. You prepared sols, okay, well and good. If sufficient quantity will be there, no problem. Because of excess of electrolyte, problem is coming. So if you want to solve the problem, we should remove that excess of electrolyte from the sol. That's only we are calling as. Yes. Now we should remove the excess of. We should remove the excess of electrolyte from sol. That only we are calling as purification of the sols. The phenomena or the concept only we are calling as purification of sols. Are you getting or no? Yes. Now we have so many techniques to purify the sols, means to remove the excess of electrolyte from the sols. Under this, first one, dialysis. I think biology you have some idea regarding this word. Dialysis means is nothing but filtration. So one type of the filtration to remove the waste materials. Generally, some people are suffered with kidneys problem. These all they are regularly going into dialysis treatment. Means indirectly by using some techniques they are removing the waste materials. Is nothing but one type of the filtration. Okay. Under dialysis, target is what? Removal of excess of electrolyte. First of all, I am taking here parchment paper bag. I am taking. Parchment paper. Already you have this word. What is the meaning of parchment paper? It is a one type of the filter paper. It is highly resistant to water as well as temperature. But compared with normal filter paper, here hole size will be small. Are you getting that? Okay. Now I am taking a filter paper. No, sorry, a parchment paper. I am taking here. Yes, I am taking here with small holes like this. Are you getting or no? Yes. Through this, I am sending solution particles. Is it passing or no? Yes. Starting with the crystalloid solution and colloids. Why solution particles is passing through this one? In the solution particle, the solute particle size will be too small. That's why the solution will be passing through the parchment paper holes. Watch. Through this, I am sending which one? Sol particle I am sending. Is it passing? No. Why? Compare with this whole size, the sol particle size, so colloidal particle size will be bigger. That's why the colloidal particle will not pass through parchment paper bag. We are catching that point. Okay, generally you know solution is what? Electrolyte. Electrolytic solution. Solution means is nothing but electrolytic solution. Electrolytic particles only we are removing, no? That's why I will explain now. Did you got main concept here? Yes. Through the parchment paper, only solution particle or electrolyte particle will be passing through that holes of the parchment paper, but not colloidal particle. What is the dialysis? First of all, I am taking one parchment paper bag. I am taking like this. Parchment paper bag is hanging here. This is parchment paper bag. In the parchment paper bag, I am taking sol. I am taking sol here. Sol means what will be there? Colloidal particles will be there. Are you getting or no? And also what will be there? Dispersion medium is there, and also excess of electrolyte is there. Electrolyte means what? Ionic combination. After dissolving, they are becoming like positively charged and negatively charged. So indirectly, electrolyte means I am writing some excess of positively and negatively charged particles. They are dangerous to us. If there are amounts like that, they are absorbing again a dissolvation of surface particle. The colloidal particles are becoming chargeless, undergoing aggregation, undergoing precipitation. Okay, now I have to take the parchment paper bag. I am taking here only writing you see parchment paper bag. Already you know the special of that parchment paper. Okay, in that sol we are taking. In the sol, colloidal particle is there, dispersion medium is there, and also excess of electrolyte will be there. Okay, now this one I kept in water, continuous water supply. Here I am introducing inlet of water. Water will be introducing here. Here water will be going outlet. Water outlet it is. What happening here anyway? If you take like this, hanging like this, what happening in that experiment? Which particle coming through the holes of the parchment paper bag to outside? Yes. Why? Because colloidal particle should not be passing through that holes. Then what happening? Whatever here, what will be there? Positively and negatively charged particles is there. Those all will come outside the parchment paper bag through the holes of the parchment paper bag because yes, they are in smaller size than the holes of the parchment paper. Like that, all positively and excess, whatever positively and negatively charges excess will be there. They are coming outside from the bag, then they will come outside through that outlet. What happened here? Excess of electrolyte will be removed. The phenomena is calling as a dialysis. I will tell you one more technique. It is nothing but electro-dialysis. Electro-dialysis, a small extra step. What is the meaning of electro-dialysis? Yes, we are doing dialysis. Yes, very good. We are doing dialysis in presence of, yes, very good, electrical field or electrical energy. Okay, in the same thing, just one extra modification. What I am doing here, I am taking here one metal rod I am taking, or you can introduce here one metal rod. Okay, that metal rod is connected to the positive terminal of the battery. I am taking one more metal rod here that will be connected to the negative terminal of the battery. Enough. Without electrical energy, the dialysis will be going slowly. Now you are introducing electrical energy. The process will be same but speed up. Why? Why? Yes, sir. Positive rod, no, it is becoming positive rod. Positive rod means what happening? All negatively particle from the bag come to the side with high speed attraction. But this what is negative? No, that's why from this bag all positively charged ions will come outside with high speed towards anode. That's why we are taking all positively particles is coming like this will be going on. Anyway, by using electrodialysis, the process will be speed up. That's it. The phenomenon will everything will be common, but the process will be speed up. Now, I am telling that one more technique here. Sometimes you ask me in a competitive examination, you see carefully. Ultra-filtration. Ultra-filtration. Okay, what is the meaning of ultra-filtration? We are doing filtration by using a ultra-filter paper. Ultra-filter paper. Okay, if you take normal filter paper, what is the advantage? What is the disadvantage? If you take filter paper, what happening in the filter paper? The hole size is very big. Yes, sir. What happening through that hole, sir? Solution particles is passing and solid particles is also passing. Separation is impossible. No. So, in the filter paper, we have to do some modifications. That's only they are calling as ultra filter paper. With that filter paper, we are using filtration calling as ultra filtration. So, what is the concept I will tell you? You see. So, we have to modify the filter paper. Initially, I am taking filter paper. Filter paper I am taking. Filter paper. In the filter paper, hole size is very big. Through that holes, both solution particles is passing and solid particles is also passing because both are smaller size than the holes of the filter paper. So now what I should do? I should prevent the flow of solid particle through these holes. So what I should do? Yes, very good, Amma. We have to reduce the size of the holes in the filter paper. We can't increase the size. What we can do? We can reduce the size of the holes in the filter paper. For that, I am taking this filter paper, normal filter paper, and dip in one special solution. That is only we are calling as colloid ion solution. What is this colloid ion solution, sir? This is nothing but 4% of nitrocellulose solution. 4% of nitrocellulose solution plus remaining 96% is ethanol plus ether. Are you getting or no? Means we have to take the normal filter paper. My target is I have to reduce the size of the holes in the filter paper. It is possible by dipping or soaking in colloid ion solution. What is the composition of the colloid ion solution? 4% of the nitrocellulose, remaining 96% is ethanol and ether. Automatically what happening? We are getting filter paper with which one? Smaller size. We are getting with the smaller size. We are getting. Okay, if you take a little bit smaller size, you can take like this. Size holes will be reduced. The concept here. Okay, then we are getting hole size reduced. Soft paper we got. Is it used for filtration? Soft means what? If you can use means it becomes like a paste. Should not. Means what I should do? How to dip this one in formaldehyde solution. What is the use of formaldehyde solution, sir? Same paper is becoming with small holes only, but it is becoming hard. It's like a normal filter paper. So whatever finally we are getting, that only we are calling as ultra filter paper. So now you can use this paper instead of this one. What happens? Instead of this parchment paper bag, if you can use this filter paper, what happening? Only solution particle will be passing, but not a source particle. Then what happening? Electrolyte will be coming outside through the holes, but colloidal particle will be stay inside the bag. So separation will be over. Did you got it? What questions may ask here? In the preparation of the ultra filter paper, process you know it, but how to do this filter paper manufacturing is important. Colloid solution you know it. Okay, after this one, the whole size in the filter paper will be reduced well and good, but it becoming very smooth and soft. But it is not used for filtration. I want to make it very hard paper. For that, we are dipping in formaldehyde solution. Then we are getting the small holes having very hard filter paper. We are getting. That's only we are calling as ultra filter paper. That ultra filter paper will pass through it only solution particle because smaller size, but not sole particle, because sole particle size will be bigger than that holes. Then filtration will be over. All of you clear? Yes, this is calling as a purification. See, now we are discussing some important concept of properties. Preparation is over now. We are discussing about the properties. Properties of soles. Very important amount. Nearly 4-5 properties will be there. We have to discuss. Under properties, we have first one. It is nothing but the colligative properties. I think you got some idea. Colligative properties. Where we studied? In solution we studied. What is the meaning of colligative properties? Properties of the solution which is depends on only number of solute particles irrespective of its nature. Bigger, smaller, colorless, chargeless, these all are not a matter. Number is very important. Such properties is calling as a colligative property. That's what I am writing here. In case of solutions. Colligative properties is directly proportional to which one? Number of solute particles. Did you got it now? Yes. Now comes into the sole. What happens? Same. Yes, very good amount. Colligative properties is directly proportional to number of sole particles or nothing but colloidal particles. Because I told already in the starting, in solution, solute, but in case of sole, dispersed phase are also calling as a colloidal particle. So, in case of sole, colligative properties is directly proportional to number of colloidal particles. For understanding, I am taking solution first. See the concept. You get finally one conclusion. You have a solution. In the solution, we have dissolving particle size will be too smaller. Yes or no? And after that what will be there? Solvent will be there. Okay now? Yes. Okay, the size of the solute particle will be how much? Less than 1 nanometer. Then only that is calling as a homogeneous mixture, calling as a solution. Okay, in this for example, number of solute particles. Number of solute particles I am taking or I am imagining like 1000 will be there. For example, like the small particles will be 1000 is here. Now, colligative property of solution will come so much? 1000 particles is there. Related to that we are getting the quantity will be approximately 1000 for example. Because 1000 number of particles is there, that's quantity whatever like relative lowering vapor pressure, elevation boiling point, depression freezing point, osmotic pressure, whatever you take, it will becomes around 1000. Now, solution is becoming so large. What happens? That number of particles will be changing definitely. Why? Such kind of smallest 1000 particles are aggregate together becoming like a one sole particle. Yes or no? The sole particle size is equals to 1 to around 1000 nanometer. Now here number of colloidal particles will be how many? 1. Those 1000 particles are aggregate together becoming like a one colloidal particle. In this number of colloidal particles is 1. In sole what I told? Directly proportional to colloidal particle number. That's why comes how much? Colligative property in sole is equals to 1. What is the relation here? Same. Just behavior will be changing. Colligative property will be changing. That's why final conclusion always in sole colligative property will be lesser than solution. That's the one conclusion. Can you give the one relation here? Just I am writing here. See. Colligative property of a sole is equals to 1 by 1000 times than colligative property of, yes, we should get 1 no, 1 by 1000 of 1000 cancel together becoming 1, but what is the conclusion? Always sole has lesser amount of the colligative property than the solution, because there are more number of particles there, very less. The relation will be colligative property of sole is equals to always 1 by 1000 times of colligative property of the solution. Did you got my point? This is one of the important conclusion from the sole's colligative properties. Is it clear? I think it is done. Wait.